Hello everyone, welcome to our video on the atom, information from the periodic table. In this video, we're going to learn how to interpret different numbers from the periodic table so we can perform different calculations for chemical elements. Please take out your notebook so you can start taking notes. We're going to begin with the concept of atomic number. Now, elements on the periodic table are different because they contain a different number of protons, and that's the only reason why they're different. It's because of the number of protons. For example, if we take a look here at the periodic table, we see that hydrogen and helium will be different from one another, and that's because this one has one proton and this other element right here, which is helium, has two protons. So let's go back to the definition of atomic number to see how can we relate these two concepts, the number of protons and the atomic number. So the number of protons in the nucleus determines the atomic number of an element. That means that the atomic number is always equal to the number of protons in a certain atom. Now, if the atom is neutral, that means that it doesn't have an overall charge, then the number of protons will also be equal to the number of electrons within the same atom. Now that we have these definitions, let's go back to our periodic table so we can see where do we get these numbers from. So here we have all the elements on the periodic table, and we're going to take a closer look right here because this information is very important. So we see that we have a box or a square. We have the element name, which is silicon, and we also have a symbol. Now the symbol for all the elements will be 1, 2, or 3 letters. Most of the time we will be dealing with the elements that only have 2 letters, but you also have to know that there are some elements that have 3 letters for a symbol. And the rules are the following. The first letter is always a capital letter, and the second and third letter will always be small case letters. Because silicon has only 2 letters, the first one is a capital letter, and the second one will be a small case letter. Now, this is pretty simple. We're going to take a look at the upper left corner in this case, which is the atomic number. So for silicon, we have the atomic number 14. What does that mean? Well, we have 14 protons in the atom of silicon. This is the information that we can get from the atomic number. 14 will be equal to the number of protons. Let's take a look at more examples. Here we have a list of different elements ranging from 1 to 10. So again, the atomic number, here we have the atomic number 1 for hydrogen, means that this hydrogen atom has 1 proton. And because this hydrogen atom, we have no more information about it, we're assuming that it is neutral. We also have 1 electron for the hydrogen atom. Let's take a look here at carbon. So the element will be carbon. The symbol is a letter C, again, capital letter, and we have an atomic number of 6. Now, this atomic number means that we have 6 protons, and because the element is neutral, or this atom is neutral, we would have 6 electrons. So again, the number of protons will be equal to the atomic number, and for neutral atoms, it will also be equal to the number of electrons in one atom. Now let's move to another concept, which is mass number. Most of the atom's mass is concentrated in the nucleus, and it depends on the number of protons and neutrons. If you remember a diagram of the atom, and I just inserted one here real quick so we can take a look at this. We see that most of the mass is concentrated in the nucleus, okay? So the nucleus will be, the particles within the nucleus will be the ones to determine the mass for this element or for this atom specifically. Remember that the electrons are very light compared to the protons and the neutrons, and protons and neutrons will have a mass about 1 atomic mass unit, and the mass of the electron is about it's close to 0, so we can just ignore the electrons. So again, the mass is concentrated in this nucleus. Now we're going to remove this picture so we can take a look at our definition, and we see that the mass number will be equal to the total number of protons and neutrons in an atom. So again, we have the addition of neutrons and the atomic number, because the atomic number will be the number of protons that we have within an atom. So this will be equal to the mass number. from the periodic table, where can we get the mass number from? So the mass number will be, in this case, right here in the upper right corner, and this atomic weight is the mass number, okay? So if you see atomic weight, that's also equal to the mass number. In this case, we have 28.09, which is the mass number, and this is equal to the number of protons and neutrons altogether for one atom. Here we have our list of the elements again. This time we added extra columns. So we see that we have atomic weight, which is the mass number right here as an added column. And let's start with hydrogen. So hydrogen has an atomic number of 1 and an atomic weight of 1. Well, it's 1.008, but we're going to take it as 1. We're going to round down. Now, in this case, when we do the difference, will be the atomic weight includes neutrons and protons, so when we subtract the number of protons, which is 1, from this one, we get a 0. 0 will be 0 neutrons in this hydrogen atom. Let's do now carbon. Here we have the element carbon, which has a symbol of the letter C, and we have the atomic number is 6, and the atomic weight is 12. When we do the subtraction, the difference between 12 and 6 will be 6. That means that I have 6 neutrons and 6 protons. Remember, protons will be equal to the atomic number. Now, all the elements will have different number, their atoms will have a different number of neutrons. So these numbers, don't think that we will always get the same. For example, the number of protons will always be the number of neutrons. That's not the case. It will be the case for some of them, but it's not a rule. So in this case, they're all the same, the number of neutrons and the number of protons, but it's not always like that. And that's what we're going to learn on our next video, which will be the video on isotopes. This is our last slide, and here this is kind of like a summary on where to locate these numbers. So again, we locate these numbers in the periodic table, and depending on the periodic table, it will have a different format. For example, here we see that this format has the atomic number, which is the same as the number of protons on the top. Here we have the element symbol, and we have the atomic mass on the bottom. Sometimes we refer to as the atomic number with the letter C. Z as in zebra. And remember that the atomic mass is always written in atomic mass units. So we would have AMUs. Now, this is a different format. We have the same element symbol, but we have on the upper left corner the atomic mass, and down here we have the atomic number. So you have to make sure that you know which format you're using. Yes, you have to double check. A good rule to follow is that the atomic mass will usually be 2 times the atomic number. Okay, remember that it's not always the case, but remember that the atomic mass is always a bigger number than the atomic number, because the atomic mass contains the number of neutrons as well, and neutrons also have mass. So that's a good way to determine which is the atomic mass and the atomic number, given the two numbers, when you're totally lost and have no idea which one is which. So that was it. This was it for this video. I hope you learned something, and I'll see you in class.